In this video, we are going to create a real tsunami using LEGO bricks. Let's get started.
Let's start small.
On the internet, I saw this construction, which will be perfect for us to understand how waves are formed. Let's not waste any time and start assembling it. What I end up with is a mechanism like this. It's a regular piston that moves up and down. At its end is attached this nozzle made of inclined parts. This will allow you to form waves more effectively. The reservoir needs to be filled with water. But stop, this is LEGO, and this is a bad idea. Let's put food wrap on top and spread it over the surface. We'll secure it on top with the LEGO bricks. All that's left is to decorate it. Finally, the simple wave generator is ready. Fill it with water and power it up. You can see the waves start to form. It looks very exciting. If you put a boat on the surface of the water, it will start to move forward because waves carry energy. In a tsunami, that energy becomes destructive. But these waves are nothing like a tsunami, and to recreate it, we're going to have to scale it up. To demonstrate this phenomenon, we need a large aquarium which we should fill with water. After everything is filled with liquid, through the side glass we can see the movement of the water in section. The water is now in a calm state. Tsunamis are catastrophic natural phenomena caused by significant movements of the Earth's crust on the sea floor. They usually occur as a result of strong earthquakes, underwater eruptions of volcanoes, collapses of mountain ranges in the sea, or large meteor strikes in the ocean. The process of tsunami generation can be visualized as follows. An earthquake or other catastrophic event underwater shifts a large volume of water and causes a change in sea level. The balance is disturbed and waves begin to move in directions away from the origin. Let's try to build a mechanism that could stir up the water mass, just like a tsunami. To do this, we need a large plate. We immerse it in the water. As you can see, when the plate oscillates obliquely, waves begin to form. To avoid doing it manually, we should attach an actuator to the plate. This simple mechanism will make the plate oscillate when the motor is energized. As you can see, small waves start to form on the surface of the water. Indeed, now the waves are not too big, and for the boat such waves are not terrible at all. It's probably the mechanism. The plate itself is quite light and rotates all the weak motor, so it is not possible to displace a sufficient volume of water. To create stronger waves, you should make a more powerful mechanism. The design will be the same as the first wave generator, only this time we'll use these motors with a block of mindstorms. These motors have the highest torque of all LEGO motors, and this feature will be very useful to us. After all, in this case, the mechanism will move a heavy piston with an inclined surface. This time the waves are more impressive, and it is much more interesting to work with such waves. But what happens to the waves that start to approach the shore? To test this, we need to build a sloping surface to simulate the rush of water to the shore. For this purpose, I took two base plates, and using the sloping parts, I started to build a slope. As waves approach the shore, they shrink, but they also become higher, slower and closer together, a process called wave shallowing. That is, in the open sea or ocean during a tsunami, the waves are not as high as they are near the shore. Ships on the open sea during a tsunami are pulled towards the shore, where trouble is likely to await them. We'll build a small town at the end to see what kind of damage our man-made tsunami can do. Powering up the engines. Yeah, some of the structures have been ripped off their mounts, but it's clearly not the level of damage we wanted to see from the tsunami. We're gonna have to fix that a little bit. Let's go outside and use some magic.
I woke up in a new Bugatti. I woke up in a new bruh.
No, God!
Oh no!
Please, no! No!
Yeah, area that's about the size of a real tsunami. A very dangerous natural phenomenon. But is it possible to resist the tsunami or at least reduce the damage from the strong waves approaching the shore?
Bruh.
Let's try a few ways to test it out. The first way would be a breakwater like this. You can often see these structures walking along the shoreline. We managed to recreate something similar from LEGO. Fix it underwater in front of the city. For comparison, before and after the breakwater, put two ships to see the difference more clearly. Turn on the wave generator, and as you can see, it gives a very noticeable result. The captain of the ship to the breakwater is definitely not to be envied. But how does it work? When the waves come, they crash against the breakwater and some of their energy is absorbed, which reduces the impact on the shore, and as you can see, it works very effectively. There are also breakwaters with holes in them from LEGO Technic bricks. It was possible to build this kind of wall with water currents flowing through the holes. This reduces the pressure on the areas behind them and allows some of the wave energy to pass through them, which reduces their destructive effect on the shore. Look at the difference between the waves before and after. There is also a way to combat waves with artificial reefs. Reefs create artificial obstacles that help break the waves. Our artificial reef will consist of LEGO bricks placed in a mesh bag. Putting such a bag in front of the shore will dampen the energy of the wave. And as you can see, it works. Waves coming from the source lose some of their energy by hitting the LEGO reef. It is also possible to protect the shore with a wave deflector. I built a similar barrier using these parts. Run the waves, and as you can see, it works very well. Due to its shape, it reflects some of the wave energy back. You put it on the shore and the water hardly penetrates the barrier. However, instead of a streamlined barrier, just bricks of the same height are installed, much more water will be scooped up onto the shore and consequently cause destruction. It is also common to plant trees or plants to counteract waves, so that the waves also hit them and do not reach the shore. We decided to use a lot of minifigures instead of trees, and it worked, but for better efficiency, you still need to install more minifigures. As a result, we got this top way of wave protection. And the winner was the first breakwater, which showed the most noticeable result. It is important to realize that there is no absolute protection against tsunamis or other natural hazards. However, a combination of different methods and approaches can significantly reduce risks and improve coastal safety. This is the kind of experiment we had today. I hope you learned something new about tsunamis, how they are formed and how they can be fought. Thanks for watching. Bye!